I'm Claire McLaughlin, and I manage Newport News Shipbuilding's Digital Capabilities Lab. Our lab is responsible for research, proof of concepts, and prototypes across various strategic technologies, augmented reality being the work that we're best known for, but also branching into Internet of Things, cloud, mobility, AI, machine learning. Beginning of the year, our group actually moved out of the engineering and design organization and over into IT and a new strategic department that is focused on our digital transformation. So for those of you that are not familiar with Newport News Shipbuilding, we are the largest division of Huntington Ingalls Industries. We were established in 1886, and we are the sole provider of nuclear-powered aircraft carriers and one of two companies in the United States that builds nuclear-powered submarines for the U.S. Navy. So while building ships that are the size of small cities and boats that can submerge and, more importantly, reemerge is incredibly complex and exciting and meaningful work. What these facts also mean is that we are a 132-year-old, very large, very traditional, heavy manufacturing company that prides itself on how well we protect our information. To the point where up until 2 years ago, there were no cameras allowed in the shipyard, including smartphones. So no laptops with cameras on them, no camera-enabled tablets, no camera-enabled smartphones, which made for a very interesting environment that was pretty insulated from mainstream technology. Also made it a pretty difficult environment to innovate in, especially when you're talking about augmented reality that is so, or technology like augmented reality that is so visual. So I will say that the journey has had its difficulties, but it has not been impossible, even though when we started out, there were many people who tried to tell us it was going to be impossible. So this is where we started. Back in 2011 is when we were asked by the company to take a look at how we could remove paper drawings and paper procedures from our build process. We wanted to be able to build directly from our 3D product model for the new class of submarine, the Columbia class. Augmented reality is one of the technologies that we started to investigate to make this digital production environment a reality. But as I said, no cameras allowed, so when you see this in this picture, our first proof of concept was actually done completely from RFIDs. We had sensors tagged to an iPad that allowed us to determine its pose, and despite some work we did with some different proprietary filters, we had a fair amount of registration errors and pretty quickly abandoned this approach and said, we've got to go investigate what it would take to do camera-based AR, and we've got to really start socializing the value that could bring to start opening some of the doors and allowing us to start on this journey of industrial augmented reality. So we brainstormed around that until about, I say brainstormed and also met with and talked with anyone that would listen to us about AR, until we had what we considered our first tipping point in 2013. So at that time, we were getting ready to build a ship structure. We had built this ship structure 13 times before. Our production curve had pretty much leveled out. And we were going to go do a pilot to test this digital build process to see if we could lower that production curve even further and remove those paper drawings. So we got a waiver to allow us to have iPads in the shipyard. At this time, it was the iPad 1, so no camera, so it wasn't augmented reality. We were just proving the value of digital. And we put that instruction into the iPad. We handed it over to the people that were going to go build this ship structure. We backed away, let them go to work to avoid the Hawthorne effect. Came back at the end of the pilot, asked them how'd the tool work, how did you guys do with the build? And they were super jazzed up, very excited. Awesome, we loved it. We built this ship structure 10% faster, from the last 13. They were so excited. To which, from our end, was kind of met with a, darn. We were really expecting something bigger and better than 10%. 10% is not going to dissolve barriers and have doors swinging open for what we're trying to do with regards to digital as well as augmented reality. And they said, no, wait, that's not the best part. It's not the whole story. When we realized the value that we had in the tool, we were able to take our experienced ship fitter who had built the last 13 of these structures, put him on a more difficult task and bring in a brand new ship fitter who had never done this work before, and he built it 10% faster. So at that time we thought, all right, there's a story there that we can work with. We can go sell that up the chain and say, look at the power of this. We need to be able to start bringing some of these devices in the shipyard and really see what they can do. To which at that time was met with, you changed too many variables. You changed the tool and you changed the ship fitter. You never know, he could be super fitter, literally was what was said to us. So we went back to our small lab and tried to work on what would be our next steps in this process, and the good shipbuilders that they were went and built another ship structure. The same one, the fan room again, with the same ship fitter, but this time they handed him back his drawings because our pilot was over and our waiver had run out. So we had collected our devices, so he built the ship structure with his drawings, and we were then able to compare apples to apples and say, same ship fitter, one with drawings, one with the iPad device, and at that time he built it 35% faster using the iPad than the drawings. So that means he was spending 35% of his time just interpreting the information that was given to him. So that was really a story that got a number that got some people's attention and allowed us to really start down this path of, if we can get this far with digital, imagine how far we can get with augmented reality and direct overlays. So as we have worked through this journey, we've seen those kind of returns over and over again, 40%, 50%. Our most successful case being a 95% reduction in schedule time on an inspection using full-scale augmented reality. And that one also came with an increase in quality. So that really allowed us to continue working and to grow the work that we were doing quite a bit. So when you fast forward to where we are today, we have a group of about 30 professionals, all different backgrounds, software developers, engineers of varying types, designers, UI, UX developers, all focused on the development of augmented reality solutions. So we build AR applications for shipbuilding at Newport News, for the Navy and other DoD customers, as well as for commercial use through a teaming agreement that we have with a company called Index AR Solutions. We have built over 90 different AR applications across those customers and various use cases at different levels of maturity. I'm not going to go too far into the use cases because I know that one's been a pretty hot topic of this conference, and I think we're seeing that there's a lot of similar use cases across the industry. What I will say is where the shipyard can be difficult for the red tape that it presents in security and other things, it is a very good test bed for testing out technologies because of how big it is and because of all of the different types of work that we do in the different environments that we work in. It allows us to explore a large variety of use cases, this just kind of being our bucketed version of those. But what I will say about this slide and what I think is important is in that top row when we're talking about inspection and work instructions and training, that is really where we are seeing our largest demand and our most successes as far as the technical readiness of the technology matching the business demand. So in that area, we have done a fair amount of proof of concepts of pilots, and we're really starting to focus more on how do we scale this technology. Whereas on the lower end, when we're talking about logistics and starting to pair technologies like Internet of Things and augmented reality and using AR to visualize sensor data, we are much more in the proof of concept phase. So I'm going to play a quick video for you guys so that you can kind of see a quick cross-section of the work that we've done and bring these use cases to life, and then I'll talk to you a little bit more about what we're doing with scaling.
Today we were going on the ship and actually doing a survey for some temporary structure for lifting pads that were left on the ship. What we were using is an augmented reality program today in which we had a model of all of the lifting pad structure along with the hull structure of the ship. Very useful to see what was there, what wasn't there, and you could actually see what was left. Locating the structure was definitely easy. I actually came up with some structure that I didn't know was there that I'm going to have to go back and do a little bit of research on.
One particular aspect of The app that I found helpful was that I could take this device to the side of the ship and stand with my mechanic and not point at a piece of paper, but look at the actual ship structure and point out exactly what he's going to need to see in order to locate himself on the ship. It's a little bit easier for them to really gain a good perspective of how this cable is going to run from point A to point B. It puts a visual representation right in front of them of what they're trying to accomplish on the boat.
So what we're doing here today is we're taking a look at our latest augmented reality application on the Woodward UGA diesel governor. So there are 3 different procedures that the crew works to with this piece of equipment. There's a removal, an install, and then a startup and adjustment procedure for this piece of equipment. An additional feature we have is the internals, where we're showing a slowed-down simulation of what goes on mechanically inside of this piece of equipment.
Augmented reality has been an important tool used in pipe fitting. We were using it for planning, but using the augmented reality, we could actually see the changes overlaid on the actual physical aspects of the ship. And we were very pleased. I was skeptical about it being useful, but that opinion has changed.
So I'll speak to this one because there's no audio with it, but this was a proof of concept that we did with the Navy that is starting to look at exactly what I was talking about, where we're using the augmented reality application to visualize data from a physical system. And this one you can see controlling the temperature. In a moment you're going to see an electrical box here pop up. You can see the augmentation there that is controlling the state of that electrical box, and then in the physical environment, when an arm reaches in here up in the top corner, if the physical electrical box state was to change, that would be represented in the AR application, really showing the use case of multiple users or sailors or shipbuilders in a space being able to visualize the work that the other is doing. So that's just really scratching the surface of some of the projects we've done, but those projects, as well as all of the others, have really helped to lay the foundation for AR at the shipyard. So the value of AR is largely understood at this point. The challenge now is scale, which I know you guys have heard a lot about at this conference. So wanted to talk to you a little bit about how we're starting to approach scaling at the shipyard. And we are doing that through the development of application templates. And what the template allows us to do is separate the development of the application and the functionality of the application from the creation and management of the 3D engineering content. We have 3 templates that we're currently strategizing around, one being step-by-step application, so a small piece of equipment that we're performing maintenance or doing training on, a compartment visualization application, which is full-scale compartment visualizations, and then our large-scale augmentations, which for us could be doing an inspection on the entire exterior hull of a submarine. The most mature of those 3 for us right now is the one we call On-Site. It is our compartment visualization app for aircraft carrier spaces. What we have found is that this particular use case, just being able to visualize a 3D product model at scale in the construction environment during the build process, adds a lot of value to a lot of different end users. For inspection cases, if you're doing some kind of a compartment closeout, the workflow management case that Randy mentioned in the video, if you want to be able to go in there as a construction supervisor and sequence work, it touches many different aspects of the build cycle. So in this particular one, which is the image at the bottom, it's being used by a painter to identify where outfitting is going to be placed in the compartment before it's there, so that he can lay off areas that need to be painted without the use of a drawing or a measuring tape. We also performed a pilot earlier this year, which was the largest scale pilot we have done at Newport News to date, which was for an entire superlift consisting of 72 different compartments. So previously we had done a compartment here or there just to prove the value. In this case, we really looked at if we took a whole entire superlift, which is, like I said, 72 compartments, and a user could walk into any one of them and pull up the product model at any time, just by putting into the application which compartment he was in. Really allowed us to look at what processes does it touch, who all can benefit from it, and get some good exposure for the application. So like I said, serves many different end users, and the real value here is this being our largest scale pilot was also one of our quickest development turnaround times. So that speaks to the power of the template and being able to have a small team of software developers that have created this template, that maintain it, that you have a backlog to increase the functionality. But all of the 3D and engineering content is for a particular use case or for a particular project can be created by the engineering and design workforce that supports production. So that really allows us to utilize the large engineering and design workforce we have at the shipyard, where we've got thousands of engineers and designers and a minimal number of software developers to help get this solution into a lot of people's hands. So it used to take us a couple of months when we were doing a compartment visualization application. When we started 4 years ago, I think was the first time we did one. We're down to where we can visualize multiple compartments in just a matter of a couple of minutes. Really helping to keep our developers also just focused on increasing our capability and focused on the technology rather than the individual use case. So a little bit about the process we try to work to. This will be repetitive to some of what you've heard the last couple of days, but I borrowed this image from an article that I read on pioneering organizational transformation, and the article stated, take action on a small scale as early as possible by validating your approach with real learning, and then amplify and scale the things that work and dismiss and learn from the things that didn't, which sounds so simple when you say it like that, but I can't reiterate enough how important it is to take action on a small scale. Don't wait to get started. And I know that concept can be difficult in some of the companies we work at. I know at Newport News, when we talk small scale, it can be relative because we plan our projects when we're building a ship by the decade, not by the weeks or months. But driving down to the right use case where you've got a good customer, the tech's ready, and there's an improvement opportunity there, bringing that end user in very early to make sure that you can put a solution in their hands and really validate whether or not the technology is going to work for them in the way you envision it to, is another key element to this. We use design thinking very early in our process to bring in the user, to brainstorm quickly, put together prototypes, test them out and see if they work in the way that they should. We also have a dedicated user experience team within the lab, as well as user experience developers on our agile teams to really make sure we are keeping the end user at the center of the solutions we're creating. Successful pilots and prototypes that generate good value or good ROI cases open the doors and create buy-in from the top, but you don't get that value without an end user picking up your solution. So really involving them in the process and making sure you're creating a tool that they want to use, that's making their job better, is critically important. Another key to success is that mutual accountability and ownership between IT and the business. And I say the end user as well, in case the business and the end user are different for you. I know that is a challenge. You don't want to take your technologists and put them into the business because they'll lose track of the technology. You don't want to take the business people and your end users and put them in IT because then they lose touch with the business. So the way that we're trying to approach that is by building what we kind of call the accountability bridge, where we have people in the lab in IT that are accountable to an area of the business, and a person on the business side who is accountable to the digital transformation. And those two people can work together to educate each other on the business processes and the technology capabilities, and really decide together where the opportunities lie and how best to prioritize those. So these are some of the key elements that have really worked for us with regards to tablet-based AR, which is really where we've exercised this process the most. But since it is a wearables conference, I'd be remiss if I didn't at least mention where we are with wearable or head-mounted displays in our case. The lab has been doing a lot of work over the years with head-mounted displays. When a new one hits the market, we bring it in, we run it through its paces. We put our applications on it, we benchmark it against its competitors, but it has yet to really be tested in the industrial environment for us. And that big barrier to entry is the safety aspect. We have to be able to put a head-mounted display on with a hard hat. That's not something you can get a waiver for in our industry. So I was really excited to see when I walked the exhibit floor yesterday how many of the vendors have their devices mounted to hard hats and recognize that challenge. So this year we did purchase the Tremble hard hat, which has the HoloLens mounts. And just last week we were down with a customer showing them how the HoloLens could be used to digitally overlay grid lines in one of our dry docks for radiation surveys. So instead of physically going and chalking off an entire dry dock, which if you saw in one of my earlier slides, we have one of the largest dry docks in the Western Hemisphere, being able to use the HoloLens to digitally show that information could result in a big cost saving. So now it's a matter of, since the tech seems viable, targeting the right production opportunity to really test that out and start to open up some of the doors for heads-up displays that we have for tablets. And that is all I have as far as slides. It looks like I have about 1 minute left if somebody has any questions.